Okay, I'm just going to talk you through the level 1 exercise. So the very first question, the graph is drawn for you. All you have to just recognise is that is all to the power of a half, okay, or the root of x. Now it's asking you, first bit is write down the point A. Point A is when x is 0, so x equals 0, y is 3. Express x in terms of y. So remember I said that comes over as a square. So y squared equals 9 minus 4x. So just rearranging that, bringing your 4x over, then bringing your y squared over as a minus, dividing everything by 4, and that is you. Then part 3 is find the area of the shaded area. Now, they're wanting you to find it in terms of the x in there and dy. So that means you put your x equals expression in there. So that's my x equals expression there. And you're integrating the y. So it's just getting you used to curling around the y-axis. So integrating that, the y reappears, which is a normal zone. Add 1, it's y cubed, and divide by it. So you've got a 4 and a 3 in the bottom, giving you a 12. Sub in your 3, sub in your 0, and just subtract the 2. Question 2. You've got this curve and the line. So always find the point of intersections. Take your curve, put it equal to the line. So quadratic, bring this over all on one side, factorise it. So you find your x points. Your y points are obviously 5 because the line is y equals 5. So next is 4, y is 5, and next is minus 1, y is 5. Now it's wanting you to find the shaded area. So if I just go back here to the question, if you notice there, the shaded, you've got your, I'll just draw it out, actually might be easier than trying to do it from the phone. So you have in here your curve, which is something like so. You've got your line y equals 5, which is here. They meet at minus 1 and they meet at 4. So what I'm doing is I'm finding the area under the line y equals 5. Now you could do that just by using it as a rectangle. It's up to the height of 5. You could do it that way, or you could do it the way I tend to do it. Integrate the top curve or the top line, so integrate 5, and then take away when you integrate the curve. So that's what I'm doing here. Integrating the 5, and then I'm integrating the curve and subtracting the 2. Sub in your 4, sub in your minus 1, and there's your answer. Number 3. Sketch the curve y equals x minus 1 squared, take y 1. So I started off with an x squared graph and moved it forward 1 to get me x minus 1 squared. Then I'm going to drop it down 4. So I've got to here. And the line y equals x add 7. So it's just a positive line going through at 7. Intersection, you'll see me working that over here. Intersection, you set the curve equal the line. So I times out the brackets, everything on one side for quadratics. Factorised it, found that they intersected at 5 and at minus 2. Now if you see my wee graph here, drop the line straight down at 5, drop the line straight down at minus 2. So I'm going to, the upper graph is the straight line 1. So I integrate it and I take away the curve between minus 2 and 5. So here's the line taken away. Now I tidied up that curve, multiplied it out, made it a bit easier to integrate. I tidied up the whole expression in there to make it even easier. And then just did my integration. So add 1, divide by it, add 1, divide by it. Don't forget the x reappears. Then I subbed in 5, then I subbed in minus 2, and I subtracted the 2. Number 4, the diagram showed you, and quite helpfully, it was colour coded. But anyway, you had to find the intersection points first. So set both graphs equal each other over on one side, factorise, etc., etc. Now, if you can look at your graph, you can see the red graph is the top graph. So it's the red graph, take away the green graph. So you can see me tidying it up. The intersection points are 0 to 3. So once you tidy up, integrate, sub in 3, sub in 0, and subtract the 2.